appreciate it. And then I would like to move on to Hongy. Hongy, are you on the line?
Yes.
Very good. So Aishwarya, if you stop sharing your screen, then Hongy can take over, and we can start with Hongy's presentation. Hongy has been looking quite a bit into federated learning. Aishwarya, can you stop sharing? Yeah, thank you very much. And Hongy, just go ahead. So Hongy has been looking into federated learning and as well as reinforcement learning. In this particular case, he will be introducing you to the next most amazing algorithm for federated learning, which is called AF DNDF. We still have to work on the naming, but at least it's something, as the saying goes. So Hongy, go ahead, take it away.
Yeah, thanks, Ian. So hello everyone, my name is Hongy, and yeah, so today I would like to introduce a little bit about our latest algorithms which we collaborate with Volvo Cars, and also share some of our latest results. Yeah. So yeah, to begin, I would like to share some of the background, and also in case some of you don't really know what is federated learning and its basic concept, then maybe I would like to try to introduce a little bit about what is federated learning and some of its the cases that has already been deployed in a lot of industrial cases and a lot of applications. Yeah. Then I would like to share some of our results, and based on my experience, I would like to summarize some of the characteristics and also the challenges for federated learning, and also this is some of the directions for our future research if we want to really push federated learning systems or infrastructures to a lot of industrial cases. And then I would like to share some of our future work. Yeah. So let's begin. If I would like to use one sentence to summarize federated learning, I will say this technique can enable machine learning engineers and data scientists to work productively with decentralized data with privacy by default. So it is really trying to improve the learning efficiency and also trying to put all of the data privacy issues, really focus on those data privacy issues. Yeah. So what is federated learning? And currently nowadays we know that because now the edge devices is exponential, the number of edge devices is exponentially increased. And those edge devices, they can constantly generate data. But we also agree that if we are getting in touch with machine learning or model training, most of us, in most of the cases, we know that if we have more data, the larger size of data, we can train much better machine learning models and can achieve a better prediction or classification performance. Yeah. So which means that with the development of the machine learning deep learning methods, those data can enable better products and also the smarter models. However, even though we have much more data and the size of data exponentially increased, but we also notice that there are a lot of challenges if we still using those commonly used traditional learning strategies. So first of all is moving those huge size of the data to the central, it usually costs a lot. So first of all, companies may need huge budgets to establish a data center. Yeah. And secondly, they may face a risk of security or privacy issues because, yeah, especially in nowadays, we have a lot of regulations to regulate the companies how to use users' information. And maybe some of the customers don't want their data to be transferred to another location, then it may cause some of the cases. Yeah. The third is the problem of data backup storage spaces, because now the data are hugely increased. But if we are trying to transfer those huge data sets to one of the single location, we cannot, but the disk, the storage disk spaces, they are fixed. And after maybe 10 years or 5 years usage, you may replace the old disks because they are running off their life cycles. Yeah, because all of those data flush in and flush out, you will wear out all of the disks. Then you may face a lot of need to cost a lot of budgets to maybe build up a new data center or totally replace all of the hardware settings. Yeah. But we have one of the solutions, and we found one of the interesting field that may solve the previous challenges, which is parallel learning. Yeah. So parallel learning, it is a distributed learning approach. It can enable edge devices to collaborate, learn the shared machine learning model. Left side is a traditional system where we should first collect all of the data at the edge, transfer those data to a single server or cloud. Then we train that model directly on the single server or the cloud. After training, the model will be deployed back to different kind of edge devices. But with parallel learning system, instead of transmitting that large size of data, we only transmit the local models, and that kind of local model will be directly trained on the edge devices. Yeah. I'll give one of the diagram to show how parallel learning works. So first of all of the edge devices will perform self-model training based on their local data set, and that local model will be updated to a global aggregation server. Yeah. And after aggregates all of updated local models, that global knowledge will be deployed back to all of the edge devices to perform the iteration again, and it will continuously trained based on the latest updated local data set. So here, all of the engineers, data engineers, machine learning engineers, they will only access combined device reports at the aggregation site. So we can really preserve the privacy issues, because all of engineers or company staffs, they have no chance to get in touch with the user's information and perform analysis on those kind of data sets. Yeah. So there are several advantages by applying parallel learning. Yeah. The first is data privacy preserving. Yeah, we can preserve the data privacy, and because we don't have to expose the user information on the internet. Secondly, we can take advantage of local computation, because with the development of those hardwares and computation capability, all of the edge devices now can really train the model by themselves without to get access to more advanced hardwares. Yeah, so we can really take advantage of all of the edge devices and perform model training in parallel. And third, we can have the fast mode deployment evaluation, so we can get quickly adapt the changing environment and get access to the latest data set at the edge. And at last, it is obvious we can save a lot of bandwidth, because if we compare the size of the data which has been generated by the edge devices, it is extremely large if we compare with the model. Yeah, especially when we are trying to implement those real-time training algorithms. Yeah, the advantage will be more obvious in those kind of applications. Yeah, there are two deployments, which is by Google. The first is Gboard. So in this case, the phone will record your the stored information about the contacts and what kind of the link or the keyboard you have clicked, and the further learning infrastructure will get access to the local data set and process the history, and then based on all of the shared model to form a contents knowledge. And that model can then give the suggestions to the next iteration of the Gboard query suggestion. Yeah. Another deployment is called federated learning of cohorts. This is some kind of the privacy preserving algorithm to replace the cookie. And this is the interest-based advertising on the website, which is, so in this algorithm, all of the user information will only be stored on the local web browser. So what kind, for example, like the link you click and the the stuff you purchase, those kind of detailed information will only be stored on the local devices. But the companies will only get the rough information, like the clustering results. So what kind of the group of people, like some of the group people are like motorcycles, or some of people like bicycles. They will only get those roughly group results from the specific similar persons. Yeah. So on the other hand, those kind of details information will not be exchanged by the servers, and the exchange from the local and the outside servers. Yeah. So here I would like to share some of our latest research results, which is performance charmers. And this project is collaborated with 4CARS. Then we have proposed a synchronous further learning algorithms of deep neural decision forest. Yeah. So here we use a synchronous version-based aggregation algorithm. Yeah, so because in the previous or commonly used further learning algorithms, they are synchronous, yeah, which means that before performing model aggregation, the aggregation server may need to wait for all of the edge devices to finish their own training round. Otherwise, it cannot perform model aggregation. Yeah. But with the asynchronous way to perform model aggregation, once one of the edge devices finish their local training round, the model can be directly updated to the aggregation server. And then based on the model version, so the age of the model, it will give the corresponding ratio to form the global knowledge, which means that the latest model will have a higher ratio in the global knowledge, while the old model will only have a smaller ratio in the whole global knowledge. Yeah, so we really want to know what is the latest the characteristics of the current data set. Yeah. And we also combine the asynchronous further learning aggregation protocol with the more advanced network, which is called deep neural decision forest. Yeah, in this algorithm, we combine the neural network and decision forest, because we all know that if decision forest is really suitable for those kind of tasks, like the classification task. But with only this pure decision forest, it has some problem, and it cannot be combined with further learning infrastructure because of its training strategy. Yeah. So here we have combined the neural network and the decision forest. So the classification performance is further improved. And also because the back propagation has been introduced, we can also add this advanced network with the further learning, this kind of the learning methods. And also by further improve the learning efficiency and the bandwidth utilization in this algorithm, when we try to update the local models, we will only select the optimal group of the decision forest instead of transmitting the whole model set. So this will result in we can further reduce the bandwidth utilization when trying to update a lot of models at the same time. Yeah. We have validated these algorithms with two open source datasets in our publication. So one is BDD 100K dataset. So this dataset contains different kind of the objects, like the small vehicles, cars, trucks, traffic lights, traffic signs, or pedestrians. Yeah. And the second dataset is the thermal dataset, so which we contains also the trucks, bicycles, pedestrians, and also small vehicles. So we have two different kind of the data sets which have totally different characteristics, where we can really validate if this kind of algorithm works or not. Yeah, with our result, we can see that with our algorithm, we can reduce about 60% of the model training time. So which means that we can largely improve the model training efficiency. Yeah, and still we can reach the same classification accuracy if we compare with those commonly used algorithms. And also, for the bandwidth utilization, we can reduce about 80% of bandwidth utilization if we compare with the centralized learning algorithm, and also 50% reduction if we compare with those synchronous algorithms like fat aggregation protocol. Yeah. So based on our experience and our collaboration with Vocars, we have found some of the characteristics and challenges if we really want to implement federated learning infrastructure in the real industrial cases. The first is the data locality, and usually it is massive decentralized naturally rising. Yeah, availability is quite limited, and it is available based on the time of the day. Addressability of the data nodes usually are obvious and interchangeable. The nodes are stateless, which also means that usually you cannot repeat the computation because also the storage spaces at the customer side, they are also limited. So you cannot really store a huge amount of data at a single edge devices. Node reliability, usually 10% may fail, yeah. And the distribution scale is massive parallel. And still the primary bottleneck is still the communication bottleneck. Yeah. So for the future steps regarding the federated learning field, first of all, we want to introduce the independent testing model aggregation functions in our federated learning infrastructure because we really want to automate all of the training and validation process in this infrastructure because we don't want the human interaction and we want everything to go automatically by themselves. And secondly, is the same. We would like to introduce some of the self-optimization algorithms on edge nodes. So which means that different kind of edge nodes can self-improve by themselves and consume the latest data set. So we can further increase the autonomy in federated learning systems. And then also we would like to investigate the data privacy enhancement, so further improve the security and privacy advantages in federated learning systems. Yeah, so this is what we would like to do, and yeah, we'll do in the next sprint. So yeah, thanks a lot. This is all I would like to share.
Excellent. Thank you, Hongy. So as I alluded to this morning, I believe that there are two important next steps that are coming together in AI. The one is that for almost all of the software center companies, we have order thousands of tens of thousands or even millions of devices out in the field. And to be honest, the computational resources in those devices are often not used to a significant extent all of the time. So I believe that using those in a solid, in a good way can be very, very effective. And then the second one, for those of you that were in the AI engineering community session this morning, I believe that systems need to start to experiment with their own behavior in order to get better over time. This is exactly what Hongy is currently working on in the space of federated and reinforcement learning. So I think that that is super interesting. There is a question in the chat, Hongy. To what degree do you think it will be possible to formally guarantee user privacy in the future of a federated learning scheme? So can we formally prove it, or is it just like what is it? The Italians say trust us.
This is a hard question, actually. So also in the academic, we are trying to. There are some of the metrics to evaluate how much and to some of what degree is we can preserve the user privacy. So they have some of the metrics to evaluate it. But in my opinion, yeah, there are some federated learning may be one of the way to do that because really we don't need to transmit the data set, and it is obvious everything is on the local edge devices. The only one of the leakage is maybe the model. Yeah. So if the model if someone can really extract the data, user data from the model, but with current research, we found that you cannot really get the details from the model. It's only like the distribution or other characteristic of the local data set. So you have no way to really get in touch with the details of what users like in the web application, what user really click the link or purchase some kind of the stuff. Those kind of details you will never know, but you may extract the distribution from the model. So, but in current research, we are also trying to eliminate those possibilities for those hackers to trying to extract those distribution from the model. There are some of the strategies to do that, but yeah, I believe federated learning will become a really good strategy to preserve and guarantee user data privacy in the future. Yeah.
Yeah, and just to follow up on that, the only work that I have seen is where I have a version of a model I train on almost, I think it's only a single data item or a data set extended with one data item. And then I measure the difference between the old model version of the model and the new version of the model. And then I might be able to derive some information about that individual data item that was used to train. So I think that if you have a sufficiently large set of additional data that you use for training, then it will become impossible to derive the individual data items, and through that privacy should be preserved. At least that's the little thing that I've seen in that context. And Marcus, if you're interested in that, I actually have been talking and writing a little bit with some of your SAP colleagues, and I'm not sure if Ulf is in the list of participants, but Ulf Nestrom is one of the people that may be able to provide you with a little bit more color commentary on that. In the interest of time, we're now 7 minutes behind schedule, and it's entirely my mistake because I do not stop my PhD students fast enough. We're moving on to menu, but not before thanking Hongy for a very good and insightful presentation. Thank you very much, Hongy, for doing this.